Okay, hi everybody. Any questions before we start this week? I will take that as a no. So this week is kind of a grab bag. We've got a bunch of little random pieces here and there that I want to throw in. And next week we're going to have some other stuff. I'm not quite sure what yet because I'm running out of topics, but I think I've got some ideas. And then the final, dun dun dun. At least assuming I got the weeks right. I believe this is week 12. So let's go ahead and talk a little bit more about properties. And what I'd like to do to start with, let's say that we were working on a, what's a good example here? Well, let's say we were doing a user interface for some type of a system. You know, maybe it might be Android, maybe it might be a desktop application, whatever. And sometimes you're going to get in a situation where you won't have enough information to assign the value of a property until a certain function is called. So let's say, for example, that we have a class myUserInterface. And maybe inside there, this system uses some kind of XML file to describe your user interface. So I'm just going to say here, pretend we have an XML file that describes the user interface. And in that user interface, different parts of the XML have identifiers associated with them. The identifier might be a number, for example. So what we might want to do is we might want to have this user interface set up and be able to locate certain parts of the user interface to update text or observe buttons or things like that. So what we might want to do is be able to find the locations of these or find these IDs when the user interface is set up. So let's say that we had a function in here called on user interface setup, and I'm going to create a little class here. This is a dummy class, XML file. And he's not going to do anything. I'm just going to pass him in. Let's actually rename him to be XML UE file. And well, we'll put a function in here. Find ID for, actually I'm doing this kind of backwards. Find widget for ID integer. So we'll pass in an ID for, I'll make it a string. I will make up my mind sometime. I've got in my head the old way of doing Android interfaces, and I don't want to use that exactly. I just want to kind of make it a little bit more generic. But he's going to return an int, and I'm just going to pretend that behind the scenes he looks up a given widget, and we'll say class widget. Let's make it an interface. And then we have class text widget, which is going to be a widget, and then class button widget. Let's say we had something like that. There, I think this is going to work for us. Do I want to call it widget? We think widget's good enough. So widgets just represent some little thing that's going to be inside your user interface. And so what I'd like to do is be able to look up what those widgets are and then return them. So I'm just going to say return button widget. Would actually look it up and return the appropriate type. Oh, I almost got through that sentence. There we go. So the idea here is we're going to be past this XML UE file representation. We can look up the things, and then later on we'll attach information to them. So in this on user interface setup file, this one's going to be called by the UE framework itself. So this is really a callback. And when your user interface is set up, the system automatically passes you the information that it's processed. And you can do things with it. So let's say that I wanted to grab a button and I wanted to grab a text widget. What I could do is something kind of like var button, which is going to be of type button, equals, well, let's put a question mark there, equals null. Oh, I said button widget. There we go. And then text widget equals null. And then inside here, when I'm actually setting things up, I could say button equals XML file, find widget for, let's see, press me, some button called press me. And this one, I'm going to explicitly cast it as button widget. Now, I don't know if we talked about the as operator before, but this is your way you cast things in Kotlin. So find widget for returns widget type. Button is of type button widget. So this could return a text widget and we could have a problem. So what I'm doing here is I'm telling the compiler, treat it as a button widget no matter what comes back. Now that could be a problem. If the thing that's returned for press me isn't actually a button widget, that's going to blow up. It's going to give us a class cast exception just like you'd have in Java. So this is one way you could do it. Another way you could do it is say as question mark. So this one will throw an exception if not found, or if wrong type. This one will return null if the wrong type. And so the as question mark is a super useful operator here for being able to chain operations, because you can use an elvis after it, for example. So we could extend that saying, if we don't find one, maybe we want to log some information. Let's create a quick little log function up here. Just so we have something that can compile. Actually, I do need to have that null there. So what I will do is I will say run that and then null. Let's see if I can get that to work right. Well, let me not go down that path. Let's just say I'll create a button if it doesn't exist. I mean, you could do something like that, but this gives option for non-null setup, something kind of like that. So what we've done here is pretty simple, pretty straightforward, but there's some grossness to it. Yes, question. Well, what's happening here is that this is an assignment from one type to another, and so the type of button is button widget. It's a very specific type, and the only things that you can actually assign to it are button widget or some subtype of button widget. So because this guy can return a super type or some other type, we need to let the compiler know, hey, I know what I'm doing here. Trust me, the thing that's coming back is really going to be a button widget. So you wouldn't be able to smart cast in this case, and you wouldn't be able to take advantage of the what is it? What's the word I'm looking for? The type inferencing that you'd normally get out of the right-hand side of an assignment like this. So in a case like that, it's basically just because the types are incompatible. Exactly, yeah. So we don't have enough information there. Yeah, no problem. Okay, so these are a couple different ways. Now, one of the things I really don't like about this, and that was really annoying when I did Android programming with the old user interface framework, was that if we want to do something with the button, so like later on we want to say button dot, let's give the button a, let's say click listener. I will say on click. And this will be a var We'll give it a callback to be able to handle the on-click. I'm going to default it to an empty lambda. So again, this is using our null object pattern to have basically a dummy object being passed in so that we don't have to do null checks. We can just call it and it just doesn't do anything if the button's clicked. So we want to change that. So I can say button on click equals something or other there, but notice what's happening here. Smart cast a button widget. Oh, so it's saying smart cast a button widget is impossible because button is a mutable property. The problem here is it might be null. So it may have been set to null, so I can't immediately just say on click. Now, if I put my question mark there, I'll be perfectly fine. But now every time I use that button, I've got to put that question mark. So I've got to do this null checking. It'd be really nice if there was a way that I didn't have to initially assign to null and then assign it there if I know for sure that I'm always going to assign it before I ever use it. And this is a case that Kotlin came up with that actually works very, very nicely. Let's create a My User Interface 2. They have something called late init variables. And what a late init means is tells the compiler, I'm going to say promises, that a variable will be assigned before, oh, here we go, it's used. I'll say read. Compiler will trust but verify. I don't know how many people were around during the late Reagan years, but that was his big thing with the Soviets, was to say, yeah, we trust you, but we're going to verify that you really did stuff with your missiles. So in this case, what the compiler is going to do is at compile time, the compiler is going to say, okay, you're telling me that you're promising that this variable will be assigned before it's ever read. I'll trust you, but then at runtime, I'm going to double check that just to make sure. And what this allows you to do is set up a variable that doesn't have an initializer on it. So we can do stuff like get rid of him and say late init var, and then do the same thing down here. And now notice the types are not nullable. The compiler's perfectly happy not having an initializer, which is not normal. If you didn't say late init, you have to have an initializer unless you override the get and the set to not use a backing field. So now that we have that, notice a couple things down here. This guy, he doesn't like it because of the nullable on him. But this one is perfectly fine. And now I don't need the question mark dot. So what we want to do here is this guy would have to do something like throw an exception if there was a problem. So we can't return null if the wrong type. I'm going to comment him out. We'll make a copy of him. And let's actually tweak him to say, if there's a problem, then I'm going to throw, let's say, illegal state exception. That's what I was looking for. So press me is either not found or not a button widget. So that gives you a nice option there. And now you'll notice here, this one's still okay because in either case, we're not setting it to a null. We can only set it to a non-null because the type is now non-null. This is super, super useful in certain situations where when the class is being initialized, you can't initialize it, but you know for sure based on the flow of the actual application that there's no way these can be read first. Now in the case of Android, this function was called onCreate, and he could be used to set up a user interface, and then that's the very first thing that's run before the user interface does anything else. And because of that, you can know that you're going to be initializing things in onCreate, and all the other functions wouldn't be called until that initialization has been completed. So that would be safe. So you want to make sure you only use this when you're super sure. So it's going to be pretty infrequently, but there's going to be certain types of setups. Usually if you have some kind of an object that you define that is run by some life cycle in a framework. So in the case of Android, you create this thing called an activity, and the framework initializes it for you and runs a bunch of functions to say, hey, the user is now seeing the screen, the user is quitting, things like that. So everything is lifecycle callback based. And so this works really, really well for late inits. And the late inits give you that ability to not have to do null checks all over the place. Okay, does that make sense? Any questions on that? So I'm going to say late init properties is what that section's about. Okay, let's go to another thing over here. Let's talk about property delegation. There's a whole bunch of things we can do with this. Let's take a class. I'll be a little contrived here. Let's say that we have a person class, and he's going to have a name and an age. But maybe we also want to have a derived property for this guy. And we can do that derived property in a few different ways. So one of the approaches that we've seen, we could say val full name, and then define a getter. Let's say description one. Our getter can say name colon age, something kind of like that. What are the advantages and disadvantages of this? Any ideas? I'm sorry? Well, in this case, you wouldn't be able to update the name, mainly because these are read-only properties. But let's compare this to this. What's the difference between those two? Why might you choose one versus the other? Correct? Okay, so that's a difference between them. What's the advantage, disadvantage between those two? Exactly. So the second one, we'll see this only executes once. So only evaluates once. I'm going to say exactly once. And then evaluates every time it's used. Now think about when description one might have an advantage. When might that be a better option? What if nobody ever uses description one? If nobody ever uses description one, you're never going to perform that computation. Now, in these cases, these strings are pretty quick to compute. But if it was something a little bit more complex that had to be computed, then you're trying to weigh the chance of, okay, is it likely that it's only ever going to be called once? Meaning either of these would be basically the same thing. Is it likely that it may never be called, in which case this one might have an advantage? Or is it likely that it's going to be called more than once? This one might have the advantage. So those are some ways that you might want to consider this. And the second one, one of the comments here was that if name or age were mutable, this would never update. So that's another consideration you want to think about here, is that if for some reason somebody changed these to be vars, this one would no longer be a good way to do things unless you only cared about the very first setup of that field. This one would be preferable because if things are mutable, you're going to get those updates. Okay, make sense so far? So what if we can take this and let's say that the value is never going to change. It's only going to change once. But let's say that we also want to take advantage of having it only ever be computed once. So maybe it's an expensive computation. And if it's never used, maybe we don't want to have that hit. So what we can do is we can use one called val description 3 by lazy, and then put this in there like that. Now, does anybody remember what that the by keyword does for us? You're on the right track there. What allows us by in general allows us to delegate to something. And we saw this before when we had some interface that has some functions in it. And then maybe we have an implementation of that who's going to have, some definitions of those. And then maybe we have somebody who's using that but wants to delegate to it. So we want to, if we want to reuse this functionality, maybe I have my foo, which is a foo by foo impl, something kind of like that. And so what that does for me is it delegates all the functions of foo to this object that I've created, or come on, fingers. Let's say 2 and 1. Or what we can do is pass in the thing that we want to delegate to. And inside this function, or inside this class, we could override some of those functions if we want. So the by provides delegation for classes, objects, or properties. And what's really nice is that that thing it's delegating to is an object that can have some behavior to it. In the case of lazy, what we have, lazy, boom, creates an object to hold a factory. The factory is a lambda that you use for the lazy, and all it does is hold on to that factory to start with. When you ask to get the value, then it says, have I executed the factory before? If not, create it. Otherwise, just return it. So conceptually, it's kind of similar if I did something kind of like this. If I said private var, actually, which way do I want to do this? Yeah, so private var description value. And actually, let's use null for it. And then I have a val, which is going to be description 4. And then we'll have a fun get, and we'll say if description value is not equal to null, or actually we'll say equal null. description value equals, I'm just going to say compute value. And we'll put in a little dummy function here. So that's basically what the lambda does. And then we just say return description value, kind of like that. Or, sorry. There we go. So this, if you've seen this kind of code before, this is a lazy instantiation pattern. And you'll see something similar to that in a lot of code where people will say, I don't want to do that computation until I absolutely have to, just in case. And what is he unhappy about here? Property must be initialized or abstract. What am I at? I'm in class person. I'm not referencing a field. Huh. It might be because I'm calling a function here that it doesn't like this. Let me just see. No. Oh. You don't say fun get there. Oh, there we go. Okay, so this is one of the few cases where I really want to use that bang bang because the null isn't being exposed. Description itself is never nullable. We're only using that null to say we haven't initialized it yet. So what we've got here is this lazy instantiation pattern. You're going to see this in a lot of code, just kind of raw code, Java code, things like that, where you don't want to perform a calculation unless you absolutely have to. So if it's expensive, this is a good approach to make sure that you don't initialize description for if you never end up using it. Now, for what we've been doing with this name and age string, it's really not going to matter. But conceptually, what I'm trying to say here is that if the value is expensive to compute, using this would be helpful. So this up here is basically the equivalent of this guy here. Yeah, something kind of like that. Does that make some sense? And we're going to talk about what's happening behind the scenes a little bit more detail in a moment here. But consider this by lazy to be the exact same type of thing as going on here. Okay, questions so far? You know, why don't I go ahead and dive into how that works? I was going to cover some of the other ones that are predefined, but let me cover the workings of what's going on here first. So let's see. So property delegation here. We got a person. Let's create a class that's going to represent that lazy. I'll call it my lazy. And the way a property delegate works is it has one or two functions in it, a get value and a set value. And those are going to be the functions that are called by the actual getters and setters when you do the property delegation. So inside here, I might have a fun get value, but you have to call it operator fun. And then you have to have a reference to the object that you're dealing with. Now, this my lazy, I could use it anywhere, but let's say for the moment that we're only going to use it inside a person. So what I could do is say this ref is a person. So that's going to mean that this that you're executing the get against is going to be some person. And then we have a property that's going to describe that person. And then the value that we're returning is going to be of some type. I'm going to assume for right now it's just a string. We'll deal with generics in a minute here. But just to keep it simple, we'll call it a string for the type. So that's going to be what our get value looks like. And let's say Well, if we're doing a lazy, we don't have a set. It's only a getter. So now we need to actually have some value that we're holding on to. So I'm going to say private value, var value is going to be a string, nullable equals null. And then we're going to do this exact same type of code here inside this get value. So we're going to do our normal lazy instantiation pattern. I'm just going to say if value is null, then set the value equal to whatever the compute lazy value is. Now, in order to do that, we need to have a compute lazy value. That's going to create that string for me. And hold on to it. And then we can return the value, bang. So the, I took away the bang. There we go. So this is the exact same pattern I talked about here, but we're just wrapping it in an object that does the work for us, and then letting Kotlin's delegation take care of it for us. So I could come in here and say val description 5 is a string. Actually, I'm sorry, by my lazy. There we go. And then have that $name, $age inside there. And we have the exact same type of functionality as the actual lazy. Now there might be a few optimizations that they do under the Kotlin version, but this gives us that delegation. It creates this object to hold the value that's going to be expensive to create, holds on to the lambdas, says how to create it, and then calls it if we need to. Once it's been computed, we never compute it again. We just keep returning that same value. Does that make some sense? So that's a custom lazy instantiation delegate. Now, a lot of times what you'll notice that the by lazy up here is a function. It's not actually a type. So we might want to create a function to do this for us. So my lazy, and he's going to take that same guy there, equals my lazy compute lazy value, something kind of like that. Oops, don't need a val there. And so now I could do the same kind of thing with a function. Just like that. And so now it looks a little bit more like what we have. Okay, any questions? This might actually also lend itself to a little bit cleaner code as far as how you can set up whatever properties you need inside your lazy guy. You don't have to have them in a constructor anymore. You could have them inside just be variables that are set up by the function or applied by the function. Or maybe there's some computations you need to do before you create this instance. That's another possibility. Okay, now just for grins, let's create a generic version of this. I'll just call it mylazy2. How about that? So mylazy2, he's going to still have this compute lazy value, but we're going to want to change strings. That's going to be the type of the property. So I'm going to say property type there. And then what we're going to do in mylazy2, he's going to have property type coming in there. And so let's see, that's going to return property type. This is going to return property type. This is going to be property type. But, oh no, that'll be good. We'll have the null there. And then let's see, so this ref, instead of being a person, we have to say what kind of object we care about here. Now we're not using that anywhere here at all. We're not doing anything with this ref. So we can just go ahead and say he's going to be an any. And that should work just fine. So let's see, is there anything else we need to do here? So compute lazy value has property type. Okay, let's try this out and see what happens. If this works, we should be able to define a couple other properties. So I'll say name string, actually, let's say name2 by my lazy 2. It's going to be Scott. And age 2 by my lazy 2. There we go. So now we have these delegates that we're using to create these. And once again, you don't want to do these for simple values like this. It's much more efficient to just go ahead and assign it to Scott or assign it to 57 instead of waiting. But if it's a complex computation, you may want to wait on that. Okay, make sense? Any questions on that? Okay, so that's a really simple read-only property that we've created here. Now, what if we wanted to create a read-write property and maybe do something with it? Now, in this case, this was useful because the thing that we needed this delegate for was to just create the property at some delayed time in the future. But let's say that maybe we have a property that we want to just log some information whenever it's accessed. So let's go ahead and create a new one over here. We'll say logging delegate. And then in there we'll have our operator fun get value with a thisref any and a I'm blanking what the other one was. Oh, the property type, yeah. There we go. And let's give him a property type. And he's going to return property type. Let's have a private var value. It's going to be property type. Now, in this case, we don't have that null situation. It'd be really nice to have some kind of a default value being specified by the user. So I'll come up here and say, let's say initial value. He's of type property type. So we'll assign him there. And, actually what we could do here, let's do a private var value property type. Boom. We don't need to have two of them. And then inside here, I'm going to say return value. And then let's do the set value, which is going to be similar, but I believe it's the last parameter. We'll find out. Something kind of like that. So right now, this one really doesn't do anything interesting at all. All he's doing is holding on to a value, returning it when we get it, and changing it when we set it. If we put some code in or around these, we can have it do something interesting. So if we want to log it, let's just use println to simulate logging. And we'll say property $property.name is being read. And then down here, it's being set to $new value. Something kind of like that. And we should be in pretty good shape there. So there's our logging delegate. Let me just make sure we don't have anything else. I think that's all good. So now if I define a person here, a couple things. Note that I cannot specify these properties in the constructor, the primary constructor for the person. I have to specify them inside the class. And that means that you're not going to be able to use delegated properties in a data class and have them show up in the toString or the hash code or the equals. You will have to manage those yourself. So if we have inside here var name by logging delegate, and then age by logging delegate, something kind of like that, Then what I can do is I can say val person equals person, println person dot name, person dot age. And then if I said person dot name equals humuhumunukunukuapua'a, then I could, then get his value as well. Let's see what happens when I run this. Okay, so we'll see property name is being read, and there's Scott to be printed, reading the age, and then property name is being set, he's being read, and so on. So that did exactly what we wanted to do. One time that I used this at my last job, I was writing an Android program that I wanted to set it up so that as you type values into fields, they're immediately written to the database. And it was something that I wanted to do because if we had a crash in the app, you could lose a lot of data that you entered in. And so I tried it out thinking it's going to be horrible for performance, but it actually worked just fine. And so really what I had was an object that delegated all the reads and writes to actual database update changes. And that worked really nicely. And then all I had to do was define objects that delegated like this. And then it was in great shape. Okay, any questions on this? So those are a couple types of custom delegates that you can define. Once in a while, this becomes a really useful tool, but like all tools, keep them in your toolbox unless you really need them. Don't pull out a tool and say, oh, this is cool, and have it be the tool of the week, because then you're going to get yourself in trouble. Okay, so that is custom property delegation. So there's some other ones that are predefined. And one way you can do this, let's say I have a class person here. And which way do I want to do this? Let's say that I'm reading in some data from somewhere. Maybe it's from a file, maybe it's from a database, but I set up a map containing name value pairs. What I can do is delegate to that map, but create type safe properties for them. And what that means here is I can just come in here and say var name by map, by values. Oh, I need to make him a property. Map string any. Why is that not working? Let me find my example real quick. I'm doing something silly. Property values could be private. That's cool. String any. Oh. This is to be a mutable map if I'm using a var. There we go. That's what I wanted it to do. So now I'm defining a couple properties inside of here that are delegating to this map itself. Now what they've done behind the scenes, because map itself doesn't have that get value and set value, they created a get value and set value as extension functions. And so now, what is he unhappy about here? Oh, I don't need that to be a property. I forgot about that. So what that does is you can actually create delegates for objects that you're just passing in, and it could be any old object. It could be a person, and maybe you create some delegates for that person. In this case, they've added in the extension functions for operator get value and operator set value. So let's see how this one works up here. Maybe I'm reading a file. So let's say pretend I read values from a file into a map. So I could say map equals mutable map of name to Scott and age to 57, something kind of like that. Now this is a mutable map, meaning that I can change the values inside of it. So when I say val p equals person, passing in that map, I'm going to need to be explicit on the types. There we go. Then I can do things like println p.name, p.age. I can say p.name equals sparkly thing, and then println, actually I should say Sparkly the Crow. Anyone get that reference? Nobody's played Demon's Souls. Oh, maybe? An old Demon's Souls reference. So we'll say p.name, and let's run it. Oops, running the wrong one. Let's run this one. So we're getting the values out of the map, and then I change the value in the map. And so now also outside here, if I say println map subname, I should get sparkly coming up there as well. That makes sense? Cool, cool. So go ahead. Sure. Mm-hmm. No, it actually it's doing a lookup on the map. So kind of what this is doing, let me see if I can just write these out. So we said operator fun map string any. Actually, I'll do it this way for the moment and see if I might be able to change the type of it. But if I have this function as an extension function, get value, and then we say this ref colon any question mark and property k class star, and he's going to return a, I guess we'll need to do here property type, see if this will work. And what is he not happy about here? Second parameter must be k property, not k class. That's better. Okay, so then inside here, what I'm going to do is I'm going to take the property name and look it up inside the map. The map is the this, so I'm going to say this sub property.name, return it as property type. And this guy is going to give us a unchecked cast, so I'm just going to say, hey, trust me, this is going to work. Probably not the best. Oh, actually, no, I really should do is do this. And then say throw, I'll just do a legal argument exception. We can finish that up. So now this, it's still going to try to cast it. What I want to do is I'm saying, hey, trust me, I'm trying to cast it to the type it should be. Let's get this warning out of the way. So I'm going to hit Alt-Enter on him and say compiler warning unchecked cast options. I'm going to suppress it for this statement. So this is basically just turning off that warning saying, hey, compiler, you're not doing me any favors here. I realize that it's possible that the thing inside this map could be any type whatsoever, and maybe this typecast will fail, but I'm covering the typecast failure here. So we define something kind of like this, and what this function does is, and this is probably almost identical to what they've defined. So what this is going to do is this function will act on the map. Well, they have defined for mutable map, I'm sure. It'll act on the map that's coming in to be able to retrieve the property from the map based on the property name defined here. Does that make some sense? Yeah, I mean, it's this is some really awesome functionality they have here, and you can do some really interesting things here. This map thing, the place that's really useful is if you want to go back and forth between an unsafe type map to type safe values, and basically you're defining a class that makes it look like the map is an actual set of type safe values. And then you can actually go back the other way. As you're making the changes, it's making the updates in the map, and then you can store that map wherever you wanted to, whether it's a file or whatever. So very cool type of functionality here. To be honest, I think I've used this once, and it was probably just for kind of playing around with it. I haven't really used it in real life, but there may be several places in real life where this could be useful. I really think of it as more of a functionality to transform between, you have a map and you want to have an object, so you have type safe values on them. Okay, any other questions on that one? Go ahead. I believe it throws an exception. Let's try this really quick. Let's say that this was a string. Let's just see what it does. So it's giving a class cast exception there. String cannot be cast a number. Oh, I believe it's going to throw an exception because it'll be like a null pointer exception. Oh, my custom one caught it. Ooh, that's cool. Let me comment him out for a minute. At least I was catching it. But let's see what type of exception we're getting. No such element exception. Okay, so that's one where it's just trying to fetch from the map and doesn't exist. Okay, any other questions on that one? Okay, so let's see what was the other one that I wanted to cover on this. Now there's a pair of things called observable and vetoable. So you can say whenever the value changes, what do I do with it? I can, report it, I can print out some information or whatever. So if I did something like, let's look on the bottom here. What might be a good example here? Well, I'll just say person2. We'll stick with that. And I'm going to say var name by delegates observable, passing in string as the type. Or I can just put an initial value and not specify that. That'll work. I need the lambda to say what to do. Now the lambda is going to take 3 parameters on here. One is going to be the property, and then the old value, and then the new value. And so inside of here, I can do whatever I want with that information. He's going to update the value inside the delegate, and then I can report it. This is useful if you had like a model view controller type user interface set up. I'm just going to say println $property.name change to $new value. We'll say changed from $old value to $new value. We'll do something kind of like that. So let's create a person2. And then I can say p2.name equals Scott, Mike, Sue, something kind of like that. And then we can, let's make sure we're calling the right one. We should see those being reported. Oh, I got to put my name back in, or my age. There we go. So now it's giving us this progression of what it changed from. So it's changing from one value to another. Make sense? Another one that I've never used. But there may be some good uses for it. I would think that this one would be useful if you had like a model view controller type setup. Let's also do one. Let's say age by vetoable. And what vetoable does for us is he gives us this lambda has to return a Boolean saying, is that value okay or not? And if the value isn't okay, it's going to ignore setting it. So we'll come in here and I'm going to say if new value is not equal to 30. So nobody can be 30 years old. And we'll come up here and I can say p2.age equals 10, 20, 30, 40. And let's go ahead and print out after each step there. We should end up seeing the printout saying 10, 20, 20, 40. Okay, so 10, 20, 20, 40. And oh, I still had that, I forgot that I still had this property change. Property changing. We'll see that it's trying to change it to 30, but he says, nope, not going to take that. Make some sense? This one, I have a little trouble coming up with good cases for it because we're not reporting any issues here. We're just ignoring the change. Okay, so now another one. If we wanted to do property delegation to another property. So if I had class person 3, and let's say that we had val name string inside there, I could create another one in here, val name 2. Let's say, let's actually do this. We'll do an example that might actually make some sense. So this might be an example of maybe initially the properties were called name1 and name2. And maybe at some point you decide you wanted to change your interface on this so that people could call those first name and last name. So what we're doing here is we're still keeping name1 and name2 in case there's old code using it, but we're creating a couple new properties that are basically just renaming those existing properties. So we have name1 and name2 there being delegated to first name and last name. So now people could call that either first name or name1. Either one will work perfectly fine here. So this is delegation to property in the same class or object. Now, if you want to delegate it to some other object, let's say that you're creating an object that you want to combine data from other things. So maybe we have class heart, and inside there we have a val heart rate, which is for some reason going to be constant. And then maybe we have a class hand and number of fingers. And let's say that you only have one hand, so we don't have to worry about additions or anything like that. And now we have a class person. What are we up to? 42? 4. Okay. And let's say that we're going to pass in, we're creating this person, a private val heart and a private val hand. And maybe what we want to do is make the person itself have a heart rate and number of fingers. So we're going to delegate to those objects. So I can say val heart rate by heart colon colon heart rate, and then val number of fingers by hand number of fingers, something kind of like that. So now this is a way to delegate to the property to a different object. And so if somebody asks a person for the heart rate, he's going to go to the heart inside that person and ask for the heart rate. If they ask for number of fingers, he's going to go to the hand and ask for number of fingers. Make sense? So that's kind of a nice way if you want to combine things. The other one is really useful if you want to rename. Mainly useful to rename properties. And then down here, this is mainly useful to aggregate properties. of child I'll just say child objects. Does that make some sense? Now again, ones that you're not going to use super often, but every once in a while they're very helpful. Okay, let's go ahead and take a break. It is 8:23. Let's start back up at 8:33. Okay, we're back. Any questions before I move on? Mhm. Yeah, if you say this colon colon something, it's exactly the same as just saying colon colon something by itself. Cool. So what might be, if you wanted to compare using a property delegate versus explicitly putting code inside getters and setters, how might you compare those two as far as advantages and disadvantages? Any thoughts? So if we took a look at this person for example, let's do one with explicit getters and setters here. So we'll call it person 5, and we're going to still keep our hand in our heart, but instead of using these delegates, what we're going to do is say heart rate is an int, and then we're going to define the get as being heart dot heart rate. And then we'll do the same kind of thing here, and we'll do the get equals hand dot number of fingers. So what kind of, if you looked at just these particular ones, what kind of advantages or disadvantages do you see? It's a little more terse, right? I mean, these ones up here, you don't have to explicitly specify the get, you're just delegating it. And this will work for both vals and vars, either one of those. Now, what if we had something more complex, like the the initializer when the lazy initialization? What might be the advantage of using the by lazy versus using an explicit getter, like what we saw up here? Let's see if we can find where I had that one. So here was where was the explicit getter? So here's the explicit getter version here versus the oh, this one up here. What type of advantages, disadvantages do you have between like this versus this guy? They're both doing the same thing, right? The big advantage you have here, I mean, first of all, take a look at the amount of code you have to write every single time you'd want to do this. The big advantage to a property delegate is if you have to do the same kind of functionality over and over and over again, and you don't want to have to type that in every one of your getters and setters. For the other one, the simple property delegating to another property, there wasn't a huge advantage there. The code difference wasn't that much. But in a case like this, we've got to create a function to get something, a value. We've got to hold on to those. We've got to have this check in here. That kind of repetitive code all over the place, which, again, if you've written lazy instantiation in Java, you'd see this same exact pattern over and over and over and over and over again. By putting these into a property delegate and being able to reference it like this, you're saving yourself quite a bit of work. And even more importantly, you're guaranteed to get it right every time. In this particular case here, if one of the places you accidentally did that, you're going to be in trouble there. The end result of this, well, what do you think the end result of this would be if I had that saying not equal to null? What do you think is going to happen when I try to get description for? And guesses are okay. It'll blow up because of the bang bang here. We get a null pointer exception because we're never going to end up setting the value. And so we get this. So the big advantage of these is if you have, repetitive boilerplate code, that can be error prone. It's really easy to make, typos or copy pastos. Maybe you had the wrong name here. I mean, a lot of this, one of the problems I had a lot with, early in Java when I'd copy and paste when I was doing a whole ton of getters and setters, every once in a while I'd forget to change the name of something. And you end up calling a getter setter and it changes the wrong actual field behind the scenes. So there's a bunch of potential issues there. It's really hard to get wrong. And you can be a lot lazier when you write it. Okay, any other questions before we move on? Okay, so let's talk about inline functions. Now, there's several reasons you might want to inline things. Don't go and inline everything. Basically, what an inline function does is it takes the code of the function and just drops it in place of where the call is. If you don't use a called function very often, then hey, an inline function could actually be quite nice. It could improve your performance a little bit. It could help avoid a stack overflow thing, so it's one less function pushed on the stack. But you can't really do it for everything. Especially when you have recursion involved there, whether it's direct recursion or indirect recursion, that can cause some problems. But there's a lot of times when there's like little functions that you're calling that it'd be really nice to just have that be code in line. I mean, think about something like how often you're going to use that for each function. And if we take a look at this for each function, we're going to see that he's listed as an inline function. That makes it so that it's much more efficient. And you'll notice how it's really just doing a loop here, right? It's just a reword of the loop. So by making it inline, it creates this loop, takes the action code, puts that inline as well, and now you don't have to create that object for the Lambda. You don't have to call a function here, pushing stuff on the stack and everything like that. It's much, much more efficient. So something like this really is exactly the same as putting that for loop here and having this curly brace be actually inline in code. If it weren't an inline function, this Lambda has to be converted to an object to be passed to the function and then executed. And so it's much, much more efficient by inlining this one. But if there was a ton of code involved there, if you have a large function, it's going to be much more efficient to have that function called instead of spelled out in every single place you call it, because that's just going to increase the size of your application. So it's going to be less efficient to transfer across the network when you're installing or something like that. It's going to take up more memory when you're loading it into the machine. But something that is basically kind of like a simple renaming, very nice there. So let's take a look at how we implement something like this. And we did something like this for one of the homeworks a while back. And sometimes there can be some issues with it. Let's start off with a very straightforward, so we'll say my for each one. Oh, wow. And I'm going to have this be a function on list. And we're just going to have this be super, super direct. So we're going to have a block here, which is going to take each of those items T and just do something with it. And what we're going to do inside here is say for item in this block item. So this is pretty much what you wrote for that assignment. We're just going to walk through some items, call that block on each item. Life's peachy. So let's see what happens when I say list.myForEach1. And then inside here, let's say if it mod2 is 0, meaning if it's an even number. Maybe I want to actually, let's make a function that does this. We'll call this foo1. Oh, these are actually, we know this is going to be ints. Otherwise, I won't be able to do anything with those. Okay, and let's do a foo1 passing in the list. And let's say what we want to do is we want to do an early exit if the number is even. And this is kind of similar. If you remember, we had there was like a find function that you had to write where or I think it was find or exists or something like that, where it would have been nice to be able to exit early. If I try to put in a return there, it's going to tell me, no, you can't do that. If I float over it, it's going to say return's not allowed here. That's really specific, isn't it? Let's think about why the return isn't involved. This lambda here is being run as a separate function. And what that means is that that function, when you say return, it would be returning, sorry, that's not the lambda, it's this one here. There we go. So this lambda is being run as a function. And if I say return here, it should be returning from the lambda call, when what we really want to do is return from the actual function that we're trying to get out of here. So the return is not in the right spot. But if I do this, that works just fine. This is what's known as a non-local return. And it allows you to get out of this function and return from this guy up here. Now I could also, I believe, do that. Is that going to work? Maybe not. No, that one won't work. I thought maybe it would. I haven't tried that before. So this lets me get out of that function there. When we call myForEach, we're calling a function, and then each time we're calling this block, we're calling another function. So there's a lot of pushing and popping on the stack going on here. So what we might want to do is inline this guy. And if I come down here and say inline in front of it with myForEach2, now let's see what happens when we create a foo2 calling it. Notice it doesn't like that non-local return anymore. What ends up happening here is that this code that's generated, this code here, the myForEach2, is just dropped in place. So that's exactly the same as taking this code and doing that. And so you'll notice when you look at this, there's no myForEach. Whoops, it should be a 2, really. Oh, that actually does work. Why does that work? Oh, I guess that is legal to do there. It just throws it away, I guess. Interesting. I didn't realize that would work. So what this does is, that did actually work. All we're doing is taking the code and replacing it like this. And now we'll notice that the return, the scope for that return, is what we wanted it to be. Well, actually, no, this return actually gets out of this function up here. Returns from, let me write this right here, foo2. Yeah, that's right. Because there's no intermediate function for us to actually return from. Now, if I did let me try a couple things out here just to make sure. Let's say 2a there. What just happened? What did I want to check? Oh, if I wanted to check if I do a return at my for each. I think this is going to act like a break, but let me just take a look here. Let's just try calling. What is with this guy? Oh, I accidentally copied that, I guess. Yeah, okay, that's better. So let's call foo2a. I just want to make sure that it's doing what I think it's doing here. Whoop, wrong one. Yeah, so the break happened. So in a case like that, when you have it inlined, if you use the label, it essentially acts like a break. It lets you get out locally. Returns from my for each two. So that'll actually get us to this spot. But that's not the same as this one where if I had just had a return, it's going to return from the whole function itself. This actually is used to say whatever this lambda is, just exit him completely. So this function call, the code that it generates is probably going to be like, something like that. It'll basically be the equivalent of that. I'm assuming that the compiler is going to change it to be something kind of like this, to be a break instead of the actual return. So when you have a return inside that, a labeled return, it's going to basically put that label in there. I should actually just use the same label. That would make more sense, wouldn't it? There. So it's equivalent to this. So I believe it's going to be changing the return to a break. I'll have to look that up sometime and see, but that would be the only thing that makes sense to me here. Well, does a return? Yeah, I won't be able to do that because it's not a function. So it would have to change it to a break in what the inline code is. That's interesting. I hadn't really thought about what that would do. But that's very convenient there. And syntactically, it makes sense to say return from this because this is actually a function call. At this point, it's no longer a function call. Okay, so that is a very basic inline. And when you do inline, it's automatically inlining the lambda inside of it. Now, what if we did something like, let's say that the lambda might be super big and we don't want to inline it. Maybe it's called a bunch of times. Maybe you're just using a function reference. What we could do is say, I want to inline this my for each function, but I don't want to inline the actual lambda itself. And so what this is going to end up doing is whatever is passed in here, it's going to keep it as an object. And it's going to call it. So the function, let's make it really explicit here so it makes a little more sense. Let's say that I had a function called item handler. And we're going to pass in an item, which is an int. And then inside there, I could say if item mod 2 is 0, return, which is really going to work not so great because we're just going to exit the handler and just keep going with all the other items. So it's really not what we're thinking. But from a function point of view, that looks right. So now I can do my foo3. Did I call that foo3? Yes, or my for each 3. And we'll put in the my for each 3. And now notice here, that isn't working. if I do a return by itself, that's not working because it would only return from the lambda itself as opposed to that guy. So this guy here, oh, my for each 3. So that one's correct. So this one will let me get out if I need to, and I should get my break happening there. That is equivalent to this guy. Let's do a val stuff to do. That's not going to work. Oh, that's interesting. I'm going to have to invert this. This is a really awkward thing to write here, but I'm going to say kinda equivalent to, we're defining that lambda as an object and then saying stuff to do item. So that's kind of the same type of thing we're doing here with those. We're just calling this item is actually still an object, and we're calling it because we're not inlining it. Now I could also use that function that I defined, the item handler, to be very similar. So if I did a list dot my for each 3, passing in the item handler like that, then that's going to be equivalent to, don't need that label there. I'm going to delete this other example I just put up here. Well, no, I'll keep it. So just keep in mind that this lambda is being treated as an object. Something kind of like that. This one's a little bit easier to understand, where I'm explicitly making a function reference there, and that function isn't getting inlined. The function's still getting called, but the my for each itself is getting inlined. Does that make some sense? Okay, so now the fun one, as if this wasn't so much fun already. This one actually, yeah, it's saying here that you're really not going to get much of a benefit out of this for inlining it. You can if you want, but you're really not going to get benefit. So let's say that we're going to use this for each function, and let's see what we're going to do. Let's use the my for each 2. Let's say we're going to use him inside of a, let's see, which way did I want to do this? Let's create a exists function. So we'll say inline fun list t exists. I'll say my exists, there's no confusion. And we'll have a block. Actually, yeah, we'll have a lambda here. So we'll say predicate. And what we're going to try to do here is call this predicate on each item, and as soon as it turns true, we want to get out. So inside of here, we're going to use that my for each that we had. So we'll say my for each, I guess I'll use number 2. Let's try that one. And yeah, he's going to say inside there, if predicate it return true, something kind of like that. Okay. Now notice the return true works fine here. It's going to actually return from the function because this guy here is inlining that block. So it can actually return from it. What was I thinking I needed to do here? Oh, but what if this guy wasn't inlined? I'll say 2x. Or is it the other way around? I wanted to do it. Maybe it's the other way around. Let's say that we had a different myExists that wasn't inlined. I'm not getting my example right. Let's see if I can find the example here. Oh, I know what I want to do. So the scenario that I'm trying to come up with here is if I have a function, let's say let's say A is inline, and he calls B, which is not inline, and he passes the parameter to it. I'm having trouble thinking of the scenario properly. So let me just write what I had written up as an example that is kind of abstract. But let's say we said inline fun foo1, and he's going to take f, which is some function. And then he's going to call some kind of function that's not an inline function. And he takes also that f. And then inside here, he's going to call that f. And this guy I'm going to call non-inline function and call f there. There is the scenario. Okay. So we've got an inline function that's calling a non-inline function and then calling the parameter inline function inside of it. We'll see here that he's going to say can't inline f here. It may contain non-local returns. So what we need to do is we're basically saying this guy here now I'm getting my head wrapped around this. I figured this out earlier, and for some reason I'm blanking on it right now. But in a case like this, now I get it. Okay, so cross inline is a way you can say that this function is going to be used inside some non-inline function that I'm calling from foo1. This tells the compiler that when he looks at the call to foo1, don't allow any non-local returns inside f. So if I took a look at, that's right, that's what this is doing. So to test the cross inline function, if I came in here, I said foo1, and I want to pass in some function that has a non-local return. So let's do a if x is 10, return. There we go. That's what it's doing. Otherwise, println x, something like that. So what's happening here is the cross inline is telling the compiler that foo1 is using f in a context where I can't do a non-local return. So if foo had that return inside of it, because he's inside of a real function, the return would get intercepted by that real function if it were allowed. Whereas right here, we're expecting this to return from foo1. Because we're crossing a border between this inline function, non-inline function, and then calling this guy here can't have the non-local returns. And so that's what cross inline does there. Now you'll notice that the compiler helped me out there when I didn't actually have the cross inline. He said, oh, you might want to add cross inline to the declaration to him there, which then the compiler can just look at this declaration and determine this return isn't valid. But you'll notice if I get rid of him, it looks like the return should be valid. So this is just a way for the compiler to kind of propagate up that guy. That's what he was. So now the only thing I can do here is say return at foo1, and then I'm okay. I'm not going to test you on that bit, by the way. If I'm having trouble remembering how to figure that out, I don't expect you to. Okay, any questions on that? Okay, so main thing with the inline functions is using inline and no inline when you want to, and how it affects any returns inside of that passed in block. This would have been really nice for you to know before that assignment, so you could have said, I can return early out. Okay, so let's look at what else I got inside here. Not a whole lot more for today. Let's take a look at, suppose we have a couple packages here. And I'll create another one that I'll call BBB. And let's create a little class inside these guys. So I'm going to say new Kotlin class, animal. Yeah, I don't know why it's insisting on putting that package up there because that's not the package he's in. So I have class animal and AAA, and let's also come on, put him in BBB. I'll fix him up there. Now, what if I wanted to use that same animal class from two different places? Let's say that it's actually really not the same. Let's say there's a little difference in the definition. Let's have him have a val name, and let's have him have a val ID. So we have one animal that has a name, one that has an ID, but they're both called animal. And let's say that I want to use them both in the same I think that'll be good. I want to use them both in the same place using two separate classes with the same name. So one way I can do this is I can be really super explicit about it. Animal1 equals AAA.animal. And he takes a name. Animal2 equals BBB animal with an ID. Oh, did I make that a string? I did. I wanted that to be an int just so it's really different. There we go. So now we see we're using two different animals by fully qualifying. And that can be painful if the package names are really long, which they should be fairly unique. So that can actually take up a lot of space. In Java, you could import one and then fully qualify the other. So I could come up here and say import AAA.animal. And let's talk about what that import statement means. And this is exactly the same that it does inside Java. All that's saying is, hey, compiler, if you see animal as an identifier somewhere, I mean AAA.animal. That's all that statement means. It doesn't actually bring any code in or anything like that. It's just used for name resolution. Now you can't import both because now you have a conflict there. And so that's not great. So we can't do that. But with this single import, I can now say val animal 1a equals animal. And then 2a equals that animal. So I can do that, and that's perfectly fine. So can import one and qualify the other. That's another option you have there. But Kotlin added a really nice little aliasing function that we can do for this. I can say import animal as some other type name. As b animal. So now I can say that, and that works just fine. So can use a import alias and direct names without packages. Yay! And this sometimes gets in the way. Sometimes it's not a problem, sometimes it is. But this is kind of a nice way to get around it. Hopefully you're not going to come across too many libraries that you use that you have to use both objects or both different type name, both same type names inside the code that you're writing. So that's one way that you can get around things like this. But what I'd like to also talk about, 1208. Let's bring a main in there. Okay. One thing I'd also like to talk about is what happens when you want to use the import on demand. And I'm going to point out a article I wrote quite a while back. See if I can find it real quick. And let's kind of simulate a situation that we used to have in Java. And I'm going to create a couple new packages here. I'm going to say package lib1, and well, let's call it myutil, and refactor rename my UI. So let's say that I have a utility package and a user interface package. And in the user interface package, I'm going to create a file that I'll call list. This represents a list of things that you're going to see on the screen. And in the myutil, I'm going to create a class called a vector, which is basically an array to keep track of things. And let's say that I want to use those in my code. So when I look at, oh, it was 1207? Okay, so when I look at 1207, I didn't mean to use that one. I'll make 1207 be this next one. If I want to use both of those, maybe I'm using a lot of classes out of each of them. Early on in Java, it was really common and really popular for people to say myui.star and myutil.star. And then in your code, you could just use things out of those. And all this star means is if I see, or if compiler sees an identifier that it doesn't recognize, look in this package. That's all the import on demand does. It doesn't actually bring in any names or anything. It just says, try this one if you see something you don't understand. So now if I come in down here and I say val list equals list, actually, this is a problem because there's automatic imports for the list type in Kotlin. So let me change the name of that. I'm going to rename this to my list. Surprise, surprise. And let me rename this one as well. Okay, so now I can just say, bring in my list. Why is that not? Did I put that in the wrong spot? Oh, it's this, the package name up here is wrong. That should fix it. Okay, back we go. Thank you, IntelliJ, for screwing me up. There we go. So now notice that it's actually saying this import is used now because it's resolving my list from it. And then I could also say vector equals my vector. And hey, life works just fine, right? So far, so good. But what happens if I create a my list class in my util? So let's see what happens there. If I come over here, I'm just going to add a class. That's all I'm going to do. I'm going to come up into here. Here we go. I'm going to say new Kotlin file class, my list. I'm just adding a class to a package. And let me fix the package name here so it's actually doing what I want it to do. And we come back over here, and uh-oh, unresolved reference my list. What the heck? What's going on here is because I added something to this myutil, now it's ambiguous. Which my list am I talking about? After my list added to myutil, ambiguous. This is a huge, huge problem, and I consider it a really bad design flaw in both Java and in Kotlin. And if you go to this article up here, I go into a little more detail on it. But the basic thing is, if you have a design feature in your language where adding something new causes existing code to break, that's a bad feature. And that's what import on demand does. Is import on demand sets you up for this problem. And this actually happened between Java 1 and Java 1.2. In Java 1.0, we had java.awt.list and java.util.vector. In Java 1.2, added java.util.list. And this blew up everybody's code because every example that you saw said import Java util star and import Java AWT star. Without realizing that that's going to blow them up. And what would end up happening is, people wrote their code, everything was fine. They set it aside for a while, and then a year later they came in, tried running it under Java 1.2, and it blew up. So this was a big problem, and this is a feature that I strongly recommend do not use. always use explicit imports. Other one, go ahead. It wouldn't compile. Yeah. Now, what happens when with this import on demand? What'll happen is the generated bytecode will contain explicit name. So when the compiler looks it up, he's going to say, okay, my list, is it in my util? If so, explicitly put the name myutil.mylist inside the bytecode. And then that way there's no worries about it. This is resolved strictly at compile time. That's a great question. And I talked about the how polymorphism works and how the resolution is done at compile time versus runtime. That has a kind of a combination effect where it can, because of that lookup, you could actually get some method not found at runtime if it let's say that the jars that you're including have changed. At runtime, when those jars are loaded onto the class path, it's not going to be able to find if the thing isn't in that new jar, it won't find it, so you'll get a crash. With this, I mean, you can get the same kind of effect. If something isn't in the jar, it'll blow up at runtime. But this particular feature here, all we're talking about is compile time resolution. Does that make some sense? Okay, so that's that. I always like talking about that. That's a good one. Let's see, what else did I have to talk about? Oh, I wanted to, let's go back to, well, this one I want to comment out. So let's look at this person here for a second. Let's say that I wanted to still require name and age to be passed in when you create an instance of a person. Any thoughts on how I might approach that? Because right now, because I'm using these delegates, I can't put name and age in the primary constructor and define them. But what else can I do? Because that can still be really useful. Go ahead. I can use an init block. And so what I'll do here, basically an init block is just the body of a constructor. So I can come in here and say, let me pass in name and age. I'm still going to define these guys exactly the same way. Oops, my monitor for some reason is thinking he wants to turn off. That was weird. It didn't realize I was actually using it. That's a bug in Samsung. So I'll copy these guys and we'll come down here. So what I do is I define those properties. I can now say init, which is the body of all constructors. He ends up getting name and age coming in. And well, we can think of it as the body of the primary constructor, really. And then say this.name equals name, this.age equals age, just like that. And so now we have the best of both worlds here. We can require name and age be passed in when you create a person, but also delegate them using some kind of property delegate. Does that make sense? So that's super useful as well. I would also like to recommend, let me find, I don't know if I mentioned this, but I was starting a series on going from Java to Kotlin, and I only have one article on it. I just never got back around to it. One of these days, This was 2019, and I'm saying one of these days, that's 5 years ago now. Oof. Um, so see that article for a nice description on constructors and secondaries. Won't be on the test, but there's, especially near the end of it, there's a lot of information on secondary constructors and superclass constructors and grouping different sets of required parameters. Because sometimes, if you have a huge number of parameters in your primary constructor, sometimes you're only going to be actually defining a subset of those together at a time. Like if you had some kind of a general location class, for example, uh, you might have a lat long in there. You might also have, oh, what's the military stuff they did? Oh, I'm blanking on it, like map group or something like that. But there's other specifications of what a location might look like, and you're never going to specify both of them together. You wouldn't say lat long and the, maybe it's geoloc that I'm thinking of, but you never want to specify both of those together. You just specify one set of them, like lat long, or the other stuff together. So you can use secondary constructors and make your primary constructor private and have the primary constructor define everything. And that can be super useful. Sometimes you might also want to think, well, in that case, maybe what I should really do is have a sealed class or interface representing location, and then two different subtypes, one which has the lat long, one that has the geoloc in it. So that might be a better design, but every once in a while you might think of a case where, hey, it would make sense to have just a bunch of parameters. A lot of them get defaults, but I'm specifying a certain subset at a time. Okay, so there's that. Let me see, was there anything else I wanted to cover today? I guess the label this would be a good one to talk about really briefly. Let's say that I have some functions that are extension functions, and we call them in a nested form. So maybe we have something like, let's give a class person and a class animal. And let's define a couple extension functions on these. So person dot do stuff, and we'll have a block being passed in, which takes a person. Actually, he's an extension function, kind of like that. And yeah, I'll just say block. Keep that simple. Let's do the same kind of thing for animal. And then we'll have a main function. And now let's use these persons and animal. So I'm going to say val person and animal. And let's say that we have person.doStuff. Note that it's telling me that the this inside of this lambda is person, right? And then maybe inside of there, I'm saying animal.doStuff. And inside there, this is animal. Now maybe I want to get to the person. Let's put a couple properties on here. So we'll say val name string and val we'll just give him an ID. Why not? And so this one we're going to have our name. Well, yeah, I'll still call it a string. Mr. Pork. And so now inside of here, let's say that I'm inside this animal.doStuff block and I want to get the person's name. Right now, if I try to say name, well, it actually has visibility because they're unique. Let's give them both an ID. Okay, so now if I come in here and say ID, which ID am I talking about? If I float on it, we'll see that the ID is, well, it's not telling me which one, but if I control click, it's going to take me up to animal. But maybe I want to get the person's ID at this point. So println animal ID is $ID. But what I'd like to also do is print the person's ID inside there. And if I just say ID, I'm going to get the animal ID each time. So what I need to do is I need to explicitly specify which of those people that I'm talking about. So if I say @person, I think this works here. Oh, no. So this @person .id, I believe is what I wanted there. Or is it person @this? Why is that not working? That should have worked. Let's just see what gets printed out. No. Okay, I'm gonna have to come up with a better example than this one because this example is obviously not working. That is very odd. I'm going to have to look up an example for that one because I apparently am not getting to this right. But there's a way that you can qualify which person you're dealing with to be able to get out of there. So I apologize. I'm going to come back to that one. To do example using this because sometimes you need to qualify to get around there. I'll come up with an example. I was trying to do one off the top of my head and it just wasn't coming. Okay, so I believe that is what I wanted to talk about. Trying to think if there was another piece here. Nope, I don't see anything else. I guess that's it for this week. Anybody have any questions on what we've covered? And I will write up an assignment on some of this mishmash and expect it to be something on property delegates, probably something with inline functions as well. See what I can come up with on that because I don't have that assignment yet. Cool. Well, anyone have any questions? Okay, have a great week. We'll see you next week.